Next problem, you'll notice that it is fairly longer. It's probably not as, I don't think this is even factorable, like what we did in the previous problem. So we're going to have to resort to the rational root theorem. Keep in mind for the rational root theorem, we got to take our factors of the last number. So plus minus 1, plus minus 2, plus minus 4, those are all our factors of 4. And let's find the factors of the first leading coefficient, plus minus 1, plus minus 2. So what are the possible factors? We can do plus minus 1, plus minus half, plus minus 2, plus minus 1 again, but we already have 1, so we don't need that again, plus minus 4, plus minus 2, but we already have 2, so there's no need for that anymore. So it looks like these are all our factors here. So as you can see, we have a total of 2, 4, 6, 8 factors that we have to try. That can be pretty tedious, right? But as I said before, let's try some basic numbers like 1 and negative 1 first. Let's see if that works. So we're going to try 1. We have our coefficients of our polynomial to be 2, negative 9, 2, 9, and negative 4. And let's go ahead and give this a try. So just doing synthetic division, 1 times 2 is 2, negative 7 times 1 is negative 7. Add that and you get negative 5. Multiply, you get negative 5. Add and you get 4. And yes, indeed, we do get a remainder of 0. That's telling us that x minus 1 is a factor. Now keep in mind, you could also try 1 again. Maybe 1 does work. If you find that if you try 1 again and you see that this gets a remainder of 0 yet again, then that's telling you that the x minus 1 just happens to happen 2 times, or in other words, that means that there is a double root there. So it is possible to try a number again, and maybe you also see that it factors out. I'm not going to try 1 again. I'm going to try something else. Let's see if negative 1 works. And so again, I'm still using the same numbers here, so I'll just do it like that. And I'm going to bring the 2 down. So we get negative 2. We're going to add and get negative 9. Multiply and get 9. Add and get 4. And oh, look at that, we still get a remainder of 0. So it turns out that the negative 1 is also a factor. So we see that that's going to give us a factor of x plus 1. So far, what do we have? We've got an f of x that's equal to x minus 1, our first factor, times x plus 1, our second factor, plus our third one is, keep in mind that this is a trinomial of x squared, x, and a constant of 0. Since we started off with x to the fourth, we brought it down to x to the third, so now we're at x squared. So I'm just going to go ahead and write it as 2x squared minus 9x plus 4. And let's see if this is factorable. So, I mean, technically speaking, again, we could do the rational root theorem. We could, try another number, maybe like half, and see if it works for 2, negative 9, and 4. But if it's a quadratic, keep in mind that you still have your old techniques of solving quadratics. You can factor by grouping and things like that, if it is factorable. And if we take a look at 8x squared, it looks like we do get factors of 1x and 8x, and we'll make them both negative. That'll give us negative 9x. So yeah, I think this is actually factorable. Maybe we can actually work with it. So let's go ahead and write these down. X minus 1, x plus 1. And we're going to get this to be 2x squared. Let me actually write it over here. 2x squared minus 1x minus 8x plus 4. And so if we factor by grouping, we'll get x out, and we're left with 2x minus 1. And we'll get minus 4 out, and we're left with 2x minus 1 yet again. So it looks like in total, our function is going to be having the factors of x minus 1, the factors of x plus 1. We have the factors here of x minus 4. And we have our, there you go. And we have our last factor right here of 2x minus 1. So there we go. We have it, this polynomial actually in fully factored form. Look at that. And it looks like it gives us all of our zeros. We have zeros at negative 1. We have our zeros at positive 1, negative 1, 4, and that'll give us 1/2. So we have our 4 zeros, and that's for our problem with 2x to the 4th power there. Okay, so you can see that we needed the rational root theorem there. All right, let's go on to the next page. And now this is what we've actually been leading up to. This is the culmination of everything that we've been doing. So why do we do the rational root theorem? Why do we want to factor a polynomial out? Well, we want to factor a polynomial out so you can get a polynomial in its factored form. And once it's in its factored form, you then see all of its factors / roots. Once you know all its roots, you can then identify all of its x-intercepts, be able to graph it on a coordinate plane, use the leading term with its end behavior and total degree to see what the graph is doing, and you'll basically be able to draw a sketch with a graph by doing everything that we've learned here. Okay, so that's going to be the point behind everything that we're learning in this chapter. So let's go ahead and put it all together. Okay, you'll notice that we have a variable x to the first, which is missing. So when I do my rational root theorem, I'm going to need to fill in a placeholder, right? Because technically this is 2x cubed plus 6x squared. Technically there's a 0x minus 8 in there. Okay, so I'm going to go ahead and write those as my coefficients, 2, 6, 0, and -8. And then I got to figure out, well, what do I really want to divide this by? So if I need to divide by something, I got to do the rational root theorem, right? We got to say, well, our roots are going to be made up of plus minus 1, 2, 4, and 8. And then this will be divided by all the factors of 2, so plus minus 1 and 2. So that means, what do we need to give a try? We need to give plus and minus 1 a try, plus minus 2 a try, plus minus 4 a try, plus minus 8 a try, obviously, right? But we also have 2 over 2, which is 1. Well, we already did that. We also have 4 over 2, which is 2. Okay, we already did that. And 8 over 2, well, that gives us 4, so we already did those. So it looks like those are all the numbers that we have, just 1, 2, 4, and 8. Oh, I think I missed some, actually. I didn't do the 1, did I? So we also have possibilities of 1/2 and -1/2 as well. But I think that will cover everything there. All right, so let's go ahead and give it a try now. Let's again try 1 and -1 first. Let's see if it works. 2, 2, 8, 8, 8, 8. Oh, beautiful. Yes, it works. Okay, so now we know that the 1 is going to give us a factor, right? So we, let's see here, where do I have room here? So I'm going to write h of x is equal to, we know that x minus 1, that's our first factor right there. And then since this used to be x cubed, it's now x squared. So that leads me to say that I can actually just use a quadratic and just solve a quadratic. Now I notice that there's a 2, 8, and 8 there. So I'm just going to go ahead and factor out the 2. And that way it just makes it a little bit easier to see the quadratic. We got x squared plus 4x plus 4. Let's just solve that then, okay? So we have a quadratic. Is that factorable? What do we get? X plus 2 times x plus 2, right? Or x plus 2 squared. That's essentially what it is, right? So therefore, if I rewrite it, I'll just rewrite it in a better form. This is our equation. H of x is equal to, if you were to actually factor this polynomial out, you would end up getting this, right? We did it. This is our rational root theorem. We factored it out. That's it in its fully factored form. Now, this is where we can use everything we learned from the very beginning of chapter 4, saying, hey, look, if this is in factored form, we know that the root is x equals 1. We know another root is x equals -2. At x minus 1, we notice it's a degree of 1. So now we know its multiplicity is 1. This is a single root, so it passes through. And x equals -2. That is a multiplicity of 2. So we know that this is a double root, and therefore we know that it rebounds off of -2. So that's some very powerful information. In addition to that, keep in mind some other things that we can actually look at is the leading coefficient. We'll notice that what we have is 2 times x times x times x again. So that's going to give us a leading coefficient of 2x to the third power. And based on x to the third power, with it being a leading coefficient positive, that tells us that we're going down to up. We're going down to up. So that's going to help us in drawing our graph. Now we know for sure that our graph is going to start somewhere here in quadrant 3. It's going to make its way over to quadrant 1. A couple of things, it will look something like this, but let's actually put where the zeros are now, right? So let's go ahead and label our graph. I'm going to go ahead and label each 2 units of length of 1. So 1, 2, 3, 4, 5. Other way around. There we go. All right, so let's label what we know. We know that the zeros are at 1 and also at -2. We know that in terms of its end behavior, we start down, which puts us in quadrant 3. We're going to make our way to -2. And then, let's see, at -2, keep in mind it's a double root, so we need to rebound off -2. So when I draw this, I'm going to make sure that my graph, that's a bad one. It's going to rebound off of -2, just like this, right? The graph is coming down. It's going to have to come down this way as well because it rebounds off -2, right? So we're going to make our way down. Keep in mind, if you remember from the last video, we talked about distance-wise from 0 to 0. This has a distance of 2 versus this has a distance of 1. So you really want to be aware of what's going on. Most likely it doesn't have a y-intercept be a minimum value. Most likely, based on the spacing here, that y-intercept, or rather the minimum value, will occur before it actually makes its way back up. And maybe the y-intercept might be a little bit above that minimum, just because of the nature of you going a further distance this way. So you'll have to make your way back up before you start coming back up to hit that 1 value. Okay, so that's something we want to keep in mind as we are drawing our graph. So let's go ahead and see what's going on here. Remember that at 1, it is a single root. So we're going to have to pass through 1 again, right? So we're going to have to come down, make our way down, and then make our way back up so that we're going to the value of 1, and it's just going to now pass through 1. Oh, that was terrible, wasn't it? I didn't go through 1. Let me do that again. So we go up and go through 1 just like that. Okay, and so you'll notice that the y-intercept is not exactly at the minimum value. It did have to come down and make its way back up before going back to 1, like that. Okay, now what is the minimum value? We can actually see it. It's actually on our function. You'll notice that if x is 0, these goes away, right? If x is 0, you're on the y-axis. And therefore, the y-intercept is the value of -8. And that's actually something that we could plot here. We can say that this value here is at -8, just like that. Okay? All right, so that is basically what we see in 4.2. A couple other things you might need to do is just solve some equations. So I will let you work on this in class. Keep in mind you can find solutions on Google Drive as well. Just a little heads up, just keep in mind if you can factor, try to factor. If you can use the rational root theorem, or if you want to use the rational root theorem, you can, but try to always factor first. It makes your life a whole lot easier. Actually, let's do one together just to show you. When I take a look at these problems, I notice, let's take a look at this one here, actually. Let's see what we can do there. If I actually move everything over to one side, just like this. Let's see, can we factor? I'm going to try factoring by grouping. I'm going to factor x squared out, and I'll be left with 2x minus 3. And if I factor a 4 out, I'll be left with 2x minus 3. Look at that. We can actually see that they both have 2x minus 3 in common. And what we're left with is x squared plus 4. And because of that, if these are equal to 0, we see that x is 3 over 2. And then over here, we get x squared equals -4. Oh, that doesn't look right. That's not a real number, is it? We're actually going to get that x is now equal to plus minus 2i. Actually, let me take a step back. Keep in mind we're taking the plus minus square root of -4. And since you have a square root of a negative number, that is what's going to give us plus minus 2i. So we're getting imaginary numbers here. Notice how the problem does say solve, and so since we're solving for all solutions, not just the real solutions, but all solutions, we're going to say that part of our answer is also the plus minus 2i. Okay? Let's just do one more, okay? So right here, No, actually, let's do the first one. I'll let you do this one on your own, okay? But for the first one, what we see here, again, is I see 5 terms here, so that's not very nice. I think I'm going to need to do the rational root theorem here. So I'm going to find plus, minus 1, 2, 4, and 8, all the factors of 8 over plus minus 1. That'll be our leading coefficient. So it's basically the same numbers, 1, 2, 4, 8. Let's give it a try. Let's get, so we have our coefficients of 1, negative 1, 2, negative 4, and negative 8. I notice that there's no missing terms here. I got degree of 4, degree of 3, degree of 2, degree of 1, and then a constant. So I don't need to fill in any placeholders of 0. All right, let's give it a try. Let's do 1. 1, 1, 0, 0, 2, 2, negative 2. Nope, that's not going to work. I'm just going to go ahead and erase because I don't have a whole lot of space here. Let's just do it again. 1, negative 1, negative 2, 2, 4, negative 4, negative 8, 8. Beautiful. This one does work. So we see that this one is going to have a factor at x plus 1 because that's what negative 1 gives us, x plus 1. And the rest of it is going to be, let's do it again. So we already did 1, we already did negative 1. I wonder if negative 1 is going to work again, actually. Let's give that a try. If it does, then that's a double root, right? Negative 1, negative 3. Most likely this is not going to work. I don't think, nope, that doesn't work. Okay, so negative 1 is not going to work again. Let's try 2. 1, 2, 0, 0, 4, 8. Yes, 2 does work. Okay, so what we now see is that since 2 works, we're going to have the factor of x minus 2. And look at what's left over. Now it's just a quadratic. It's got x squared plus 0x plus 4. So we have x squared plus 4, basically, equals 0. Oh, so since, if you notice this problem here, this is going to give you roots at negative 1, also at 2. But look at what happened. We got the x squared plus 4, which is very reminiscent of what we saw in this previous problem here. Let me change colors. Very reminiscent of what we saw over here, the x squared minus 4. But because this one is saying find the real solutions, these are not real solutions, right? So because these are not real, you're getting plus minus 2i here. Let's not include those. Your only answers are going to be negative 1 and 2. So make sure you read the directions very carefully and just answer what it's asking you for. Okay, so we don't need the imaginary numbers here. All right, I think I'll stop the video there, and then you can finish this last one on your own.